On the next Built to Last, we take a look at water conservation by seeing how water plays a role in our community. My guests from the Metropolitan Planning Council and Aurora's water treatment plant invited me to see the operation. Next on Built to Last.
On this episode of Built to Last, we'll focus on water conservation and how it plays a role in our communities. First, we'll see how the Metropolitan Planning Council helps prevent flooding by turning a quarry into a reservoir. We'll head out to Aurora to visit a water treatment plant and learn how we get our water. Then, we're off to a water reclamation plant to see what happens after we use it. The Carpenter millwrights show us how skilled labor and their standard of precision guide their work with the pumps and couplers these water systems use. All this and more next on Built to Last. Located in South Holland, Illinois, the Metropolitan Water Reclamation District of Greater Chicago has been busy transforming a limestone quarry into a reservoir serving as an extension of the Deep Tunnel project.
The Water Reclamation District targeted this location as a great location to continue the Deep Tunnel project.
How is it determined kind of to target this as part of this extension?
Well, I think geographically. So we want to, we're a countywide agency. We want to make sure that we have this deep tunnel system in place to service all of the communities throughout the region. And so the deep tunnel itself holds about 2 billion gallons of water, but then you need that extra area where you can hold that volume of water since we're getting these intense rainstorms.
With a potential of holding 7.9 billion gallons for rain and sewer water, the quarry's size cannot be underestimated. From the floor or through the tunnel, the perspective seems more like a canyon than a quarry.
You mentioned about the benefits for the area. So this it becomes a relief then for these communities that normally would have problems with flooding.
Right. So you have a combined sewer system primarily in this area, and what that means is you've got rainwater as well as wastewater together in the system. A lot of those areas are usually older systems, so the infrastructure is a little older in terms of the local sewer systems, and so you need relief in those areas. We've got 14 communities that are going to be helped with this reservoir, and the southern part of the city of Chicago.
The circumference walls were grouted and a 6-foot concrete base was poured to prepare the quarry for its new life as a reservoir. In addition, millwrights installed 4 electronically operated gates to control the flow of the water.
So then this is really a great benefit for the community in the surrounding area here then.
We think so. We've invested a lot of time and money throughout the years. The Deep Tunnel project was conceptualized in the 1960s to address flooding problems, and they started construction in the 1970s. The tunnel part was completed in 2006, and we have seen a reduction in flooding events. But we also have an increase in the intensity of rain that we're getting due to climate change. So the combination of the two has definitely lessened the flooding that's occurred, but we're also looking at green infrastructure to complement what we have built in our deep tunnel. What I mean by that is having projects that have green roofs, rain barrels, permeable pavement, bioswales, anything that's going to capture some of that water on the front end. So I think if you have all these sort of tools working together, we can make an impact.
the Metropolitan Planning Council. We're an 85-year-old organization now based here in the Chicago area. We work on a range of regional development policy issues. We do a lot of work both in the Lake Michigan area, but also out here in the area of the region that uses groundwater, trying to get communities to work together to manage shared water resources that, they cross borders, whether it's in a river or groundwater or rain, and you really need collaborative solutions to those problems.
Dave, can you kind of give us an overview of the plant operations here that you're in charge of?
Sure. Yeah, Aurora is the second largest city in Illinois, behind, of course, Chicago. And so we have a 42 million gallon per day lime softening water treatment plant. We take river water from 3 different sources: surface water from the Fox River, groundwater from deep wells, groundwater from shallow wells, blend it together, treat it through our lime softening process. That's the tanks, the vessels you see behind us. We disinfect the water after filtering and then pump it out to Aurora's residents.
Now, one of the topics we wanted to talk today, and the two of you work in conjunction with, is about water conservation. Through the years, everything has gotten to the point where water sources, whether the abundance or lack of, has affected a lot of communities and how they handle these issues. What are some of the challenges, Josh, that you see as water conservation and programs that need to be implemented?
Sure. So across the country, one of the main challenges for water conservation is that people like to do a lot of things that use a lot of water, right? And it's just become part of modern life. We use a lot of water. Conservation, the challenge is that people think that water is infinite and so they don't have to conserve. So there's different tensions in different places. The reality is, though, our plumbing fixtures, people's preferences on lawn watering, these things are changing over time as people learn more and as technology improves. So we are seeing water consumption on a per person and per household basis declining pretty much everywhere, but particularly around here.
So is that what you're finding holds true, Dave? Because obviously this is a growing community. This is what a lot of municipalities are dealing with as communities were initially small and they start to grow and populate, that obviously water sources become an issue to meet the needs of the people.
Yeah, we certainly have seen per person usage decline since the 1994 federal plumbing regulations came into play. It's been a 29-year trend. I don't see it slowing down. Will eventually. Also, with the conservation ordinances that have been passed, like Aurora has, we've seen some of our peak demand days decrease also at a significant amount. That leads us to then better conserve our resources. Out here, deep well water is being used by many municipalities, and so that impacts the amount of water and the availability and ultimately the quality of the water there. So conservation is something that we do stress here in Aurora, and we do practice with some success.
Okay. And do you find that the public is open to these means for water conservation?
Sure. It's a culture change, as Josh mentioned, so it did take a couple years. We do have the ability to find people. Typically, we take an educational bend to it. But yeah, a lot of times neighbors report on other neighbors, but I think as a community as a whole has sort of embraced it. It's been in effect for 8 years now, and so it's just sort of standard practice, not only in Aurora, but also getting regionally in the Chicagoland area.
Now, Josh, you kind of work hand in hand with communities like this as far as water conservation. Are things introduced more programs through education, or how do you get the word out there to get some of these things implemented?
You simply can't go to a hardware store or a plumbing fixture store these days and buy a water inefficient product, right? Everything, because of the standards Dave talked about, because of the US EPA's WaterSense labeling system, everything is more efficient than it used to be. So their education isn't really necessary. There you actually just need turnover and fixtures and things like that, and you get more efficiency.
Dave, are people trying to be more conscientious of what goes in to the rivers and the waters around here?
Well, I think so. I mean, in many communities you'll see a symbol for a fish that's right next to the stormwater inlet. Of course, stormwater reminds people that, hey, what I dump in this grate doesn't go to the wastewater treatment plant, it goes to the river, which of course then we use as raw water source for us. So I think that concept is coming around, the whole environmental concept of the water cycle, where the water that we use and drink today gets recycled, evaporated, it's rained. That whole concept I think is being reinforced in schools so people have a little better idea of that, but reinforcement toward conservation and protecting that cycle and that resource is important, not only for our community, but all communities, especially ones that have less of a resource than we do here in Aurora.
I think if you start to bring that back into people's homes, whether it's through water bills or Twitter or the occasional commercial on TV or programs like this, the less we'll have that out of sight, out of mind problem that we have, because water systems, they're just never going to be like roads and bridges where you see them every day, you know when there's a pothole. We need to do more to get this into people's consciousness.
The Stickney Water Reclamation Plant. This is the largest wastewater treatment plant in the world. We treat on average about 700 million gallons a day. At peak capacity, we can pump 1.44 billion gallons in a day. And how we do that, to start off with, are these main sewage pumps. The pumps are raising the wastewater around 55 feet up into the first process. First process being the aerated grit tanks. That's these long tanks headed west here. Purpose of the aerated grit tanks is to get the grits out, sand, stone, rocks, and so forth. Get it out. Those are abrasive. You don't want those in the pumps, pipes, elbows, and so forth. They do it by stirring the water up. You can see how it's stirring. The one side of the tank has air and it's stirring, making a nice cyclical motion. Keeps everything stirred up. The grit will settle to the bottom. Then we'll get that out to a landfill. Once it's been degritted, we're going to head off to these tanks out in the distance. There's 20 of them. They're called primary settling tanks. Just a big 15 feet deep tank. The wastewater goes in for about an hour and 2 hours. Physical process again. Gravity's going to make that settle out, and fats, oils, and greases will rise to the top. So there's boards, like a Caterpillar track. The boards will pull the fats, oils, and greases, or scum we call it. The boards will go down to the bottom and then pull the sludge to a pit. That pit, the sludge will be collected and then sent off to another process for the solids processing. Once it's gone through these primary settling tanks, we have the secondary system.
Okay, that's over here?
That's over here. So those long tanks in the distance, those are aeration tanks. So what didn't want to settle in these primary settling tanks are, it would settle if we let it sit there for a week. But we're in a hybrid process. We want to do the job in about 12 hours. So what wasn't settleable, we put it in this aeration tank where there's bacteria, and the bacteria is eating this. It's food. I provide oxygen to stir the tanks, as well as provide air for the bacteria to respirate and eat the food. When it eats, it kind of gets heavy and wants to settle. So now it's in its settleable state, wants to settle out. These round tanks here,
Sure.
these are final settling tanks. A round tank, 126 feet in diameter, about 15 feet deep. Wastewater comes up through the center, from the aeration tank. The solids from the aeration tank comes up through the center, settles out, clean water comes to the top, goes over those weirs. You can see in those tanks, there's circular troughs. That's clean, that's 99.9% clarified, cleaned. It's going to the canal. So in between 8 to maybe 12, 14 hours, I've cleaned it from a medium gray to pretty clear, almost drinkable water.
Well, and this process goes on all day long?
Every day, 365 days. We have little diurnal flows, midnight, 3 a.m. we'll have less flow, and more in the morning when people have taken their showers and so forth. But yes, it's 24/7.
Great. So this kind of gives us the overview of the whole complex here as well.
Yeah, what you're looking at there is half of the plant. As batteries C and D, I also have another batteries A and B. So this is a good view of how my liquid stream process works. The solids, the sludge from the bottom of these tanks then goes to another complex, or digesters, kind of like your stomach. It digests the food.
Millwrights are construction professionals who work primarily with machinery, pumps, and equipment requiring precision. Millwrights install, maintain, diagnose, and repair equipment such as compressors, pumps, conveyors, gas and steam turbines, monorails, and extruders. Precision is the standard work product of the UBC Millwrights. These members consistently participate in training and skill enhancement classes to become experts in the use of tools and instruments that they must master. A keen eye for the perfect fit is a primary asset for millwrights, having to sometimes work with specifications requiring tolerances to 1/1000th of an inch. UBC millwrights are known throughout the United States and Canada as being the best trained and most well-prepared for any project. Training includes technical categories such as rigging and signaling, aerial lift, machinery alignment, optical alignment, forklifts, scaffolding, welding, and bolt tensioning.
Whether you're in a car plant, a food plant, water reclamation plant, everything uses pumps, to move the product, the pump and motor. The pump is the actual machine. The coupling is what couples the pump to the motor. So once the pump is rebuilt and then they're going to align the motor to the pump, well, that's another class they do. They call it, shaft alignments. They have to align the two shafts, which is coupled together with the coupling, and they got to get that usually within 1/1000th of an inch, perfect alignment of each other. Well, the millwrights, they get different training up to that point, with the pumps and stuff. When they get to the pump, part of their training, we have them actually take a pump apart. They take the packing out, they repack it. They'll pull the power end apart. They take the bearings off. They mic the bearings. They check the shaft. They figure out mathematically how much they got to heat that bearing up to make it fit on the shaft if it's an interference fit. They got the mechanical seal. They got to set the mechanical seal in the correct position. The blade clearance on the impeller. They got to set the proper impeller clearance. So they totally disassemble the pump and rebuild it. They could do something as simple as a straight edge of feeler gauge to get it, which is not as accurate. Then they got dial indicators. And you put a dial indicator on it, you roll it around the coupling, and those reads within 1/1000th of an inch. Then using a formula, they can figure out how much shim they got to change to get it correct. And then we also have lasers out there. We have a couple in our shop too, and they train on how to set the laser up, how to punch in the correct dimensions and all that, and how to read it and make the correct moves to get that motor aligned to that pump. Well, with the water plants and water filtration plants like that, that's the majority of their equipment in there are pumps and motors. And so millwrights got to know how to set the pump correctly and safely, and put the motor in with the pump and align it so it runs efficiently without any breakdown or downtime. Almost anything mechanical in the water treatment plant, but you have the traveling screens there, which just skims the water or whatever. All the pumps involved in it, putting the new pumps in, putting the motors in to align it to the pumps. So the pieces of equipment are, some of them are millions of dollars, and when you want that thing to be aligned perfectly, because if it's not aligned right, well, you're putting wear on the seals of the pump, the bearings, bearings on the motor. All that stuff wears out. And not only if it's not aligned right, it's also drawing more electricity. The more precisely that it's aligned, easier it's going to run, longer it's going to last, and it's going to save the customer at the end.
Safety is a critical component of the UBC millwrights training, ensuring the knowledge level is maximized for confined space, disaster response, fall protection, OSHA 10 and OSHA 30, ergonomics, bloodborne pathogens, first aid, CPR, and automated external defibrillation. TUBC's Millwright program actively seeks out industry partnerships such as the Water Reclamation District of Greater Chicago with the goal of providing the customers exactly what is needed on the facility.
Today we're here in the greenhouse. This is part of the facility here, and I know there's a lot of new programs and stuff that they're trying to get implemented. Can you explain those a little bit?
We're really excited about this. Like I said, we're going in this great direction. Sustainability is one of our really prime issues that we're looking at. And as part of that is we want the agency to become energy neutral within 10 years. And we're 2 years into that. And how we're doing that is first we're capturing the methane gas from our process because our agency treats wastewater and manages stormwater. And treating the wastewater, part of that process creates gases. Capturing the gas, converting it into energy, we use that energy and make our facility more efficient. Number two, the solids and the liquids that come to our plant, the solids are being made into fertilizer. We currently give it away as a cover for athletic fields or golf courses, but we have a never-ending supply of it, as you know. And so what we're going to do is make sure that it's in compliance with the EPA regulations and eventually be able to market that product.
We noticed we have a couple different things going on here. Is this an example of some of the stuff that's being done?
Absolutely. So the solids that I was talking about, we refer to as biosolids. And we have the greenhouse here in order to see the effects of our end product and see what we can grow, how it's growing, and the effect on the plant, and what we can do to improve that.
Okay. What are some of the other things that'll be taking place?
Well, another thing is the liquid part. We call that effluent when it comes out of our plant, and we're looking towards trying reuse of that effluent. How can different agencies or industries use our effluent? So for example, computer companies have cooling towers, and they could use our effluent for that purpose. You don't need to use potable water for that purpose. We want to conserve that for human consumption. You can use effluent for that type of thing. We're also looking at phosphorus recovery. So our process creates wastewater, and we can capture phosphorus from that and convert that into fertilizer. We're also looking at algae and how that can be used as a method of extracting phosphorus from our processes. We're really excited about that. We're looking at a lot of different ways to use our wastewater, a lot of different ways to use our biosolids, capturing our gases and using those to make our facility more efficient.
Okay, so this is quite a difference from how the city initially operated, 100 years ago.
Absolutely. Our agency is steeped in history. We were created to protect the water environment, and because back in the 1880s, Chicago put its waste in the Chicago River. The Chicago River used to run east into Lake Michigan, which is the source of everyone's drinking water back then as it is today, and that caused a lot of problems, having that waste go in there. The state legislature creates our agency, and one of the first things we do is reverse the flow of the river to protect Lake Michigan. Over the 1920s and 30s, we start building our treatment plants to take that wastewater and protect the growing population in the Chicagoland area.
The carpenters and millwrights work closely with product manufacturers to ensure that product efficiencies are maximized. Through these partnerships, the Carpenters Union continues to be a global leader in keeping our fresh water system efficient and safe.
The line given here is that he doubled his sales in the second year. He sold 2 valves. But after that, in the next dozen or so years, the marketplace acceptance of the valve for all of its benefits really started to take off. So the growth was pretty significant.
Marketplace acceptance fueled the company's growth, and by 1971, the Franklin Park plant was in full swing. With an emphasis on design, the company continues to be a vanguard for water conservation, helping to reduce a one-time industry standard of 6 gallons of water per flush.
Well, in the commercial space that we deal with here at Sloan Valve Company, that average continues to drop. Back in the 80s, it was 3.5 gallons per flush on a toilet. It graduated down to 1.6, and now I'd say the norm is becoming 1.28 gallons per flush.
The original flush valves were in the realm of 6 gallons per flush, and there's been increasing focus on reducing those, and Sloan has always been a leader in that. So going from down to 3.5 gallons per flush, then in the early 90s, 1.6 gallons per flush. In fact, we have products now that deliver a precise controlled meter amount down to 1.1 gallons per flush, and even lower in some of our other applications. So it's very important from a water conservation standpoint, but the trick is that you've got to control the water with much more precision, which really puts a heavy emphasis on your design and your process, and thereby your manufacturing.
With a 4th generation at the helm, continued control of the design, engineering, and manufacturing process has led to a number of innovations in commercial plumbing.
One of the things that we're excited about at Sloan is the introduction of our reclaimed water valve. When you think about it, why are we using potable drinking water to flush toilets? So one of the things that's happening, particularly out in California where they have real drought issues, is they've gone to using reclaimed water, which historically has been used for irrigation, but it's a harsh environment for flush valves. So there's a lot of chlorine and difficult corrosive elements that are in that reclaimed water. So we've designed a flushometer that can stand up to those harsh conditions.
We're fully integrated, so we produce the bodies of the valve products itself, the components, and then every day we have trucks delivering product back and forth. So we do all of the fabrication, the machining, the polishing, the plating, and then we assemble, along with what we make as well as some purchase components. But the vast majority of what goes into the valve we make ourselves and deliver it literally around the world from the headquarters location here in Franklin Park.
I'm Bruce Obora. Thank you for watching this episode of Built to Last.
Visit the Built to Last website to learn about these topics and more.